Okay, in this video, we're looking to state the domain again. We've been talking about how to protect fractions, how to stop them from being undefined. And we said that we cannot have a zero occurring in the denominator in order to get that to happen. And we've also been talking about protecting radicals, specifically even types of roots. And this is a square root. Here you see that we have a combination of both of those issues. So the first thing that you're going to go and do is you're going to look at the denominator, because again, that's the only thing that really, well, it's the thing that you need to concentrate on the most. I'm not going to say it's the only thing that matters. In this case, we want to make sure that this does not go negative. So if you keep it above zero, that entire expression called the radicand, if you keep it above zero, now in the last problem where I was working with a radical that was not in the denominator as this one was, I said to keep it above or equal to zero. But in this particular case, since we not only want to protect this radical, so we don't want this to go negative, that is what that accomplishes, keeping it above zero. But we also don't want it to be equal to zero. So I have taken away that little equal sign that I used previously when I was just trying to protect a radical. Here we have a radical, plus we're also trying to protect this denominator. And the denominator cannot be equal to zero. So that's why you don't see me using that. Now you're going to solve this with an inequality. I'm going to subtract 14 from both sides. 0 take away 14 is 14. Then remember, one of the rules when you're solving an inequality is if you divide or multiply by a negative on that very last step when you're trying to remove this coefficient, it makes this switch around, flips the direction of the inequality symbol. So instead of greater than, it'll be less than. That's only when you have a negative coefficient that you're trying to divide or multiply away. So here you're going to have x. This divided by this is 7. And that is your domain, stated as an inequality. Now, in order to take this domain and put it in interval notation, I think it's best if you draw out what this inequality is saying. Just put a 7 and go and draw or shade all the numbers that are less than 7, which is exactly what this says. You're just making a drawing on this number line, and only because it helps you to state the interval properly. Okay, so you want to state all the numbers that it's allowed to be, which is represented by this shading, all the way up to, from negative infinity, all the way up to, but not including 7, which is why that is an open circle. Because there's no equal sign here, I couldn't put an equal sign, when we set it greater than 0 because the radical's in the denominator. So we're going to say in our interval notation that it's anything from negative infinity all the way to 7, non-inclusive of that 7. And that's your domain in intervals notation.